Have you ever wondered what would happen if everyone on Earth jumped at the exact same time? It sounds like a totally wild idea, doesn't it? Like something straight out of a science fiction movie or a cartoon. But guess what? Asking these kinds of fun, what if questions is a fantastic way to explore some really cool science. Imagine a global countdown. 3, 2, 1, jump! Would our planet actually shake? Would it wobble in space? Let's dive into this amazing thought experiment and see what science has to say about it. After all, science is all about curiosity and exploration. First things first, let's talk about just how many people we mean by everyone. As of today, in 2025, our planet Earth is home to more than 8 billion people. That's 8 billion individuals. It's a number so big it's hard to wrap your head around. If you tried to give each person a high five and it took 1 second per high five, you'd be high-fiving for over 253 years without a break. That's an incredible number of potential jumpers, all ready to leap for science. Each and every one of those people adds their own little bit of mass to our grand global jump. Now, for our great jumping experiment, let's imagine we could magically bring all 8 billion of those people together. We'd need a super-duper large area, wouldn't we? Picture a vast flat plain, maybe the size of a small country, with everyone standing shoulder to shoulder. Can you see it in your mind's eye? People from every nation, speaking every language, all united for this one single synchronized leap. It would undoubtedly be the largest gathering in the entire history of humankind. The atmosphere would be electric, buzzing with anticipation and a shared sense of wonder. They're all watching a giant screen, eagerly awaiting the signal. The tension is building, little kids are bouncing with excitement, while adults are looking on with a mixture of curiosity and amusement. Everyone has practiced their very best jump, whether it's a tiny hop or a big enthusiastic leap. The most important part of this experiment is that everyone jumps at precisely the same microsecond. This perfect synchronization is crucial for our scientific investigation. Can you even imagine the sound of 8 billion pairs of feet hitting the ground? It's quite a scene to think about. And then, the moment arrives. Jump! 8 billion people push off the ground using the power of their legs. For one fleeting, incredible instant, the entire human population is airborne. Think about that. Every single person on Earth, momentarily suspended between the ground and the sky. It's as if the whole world is collectively holding its breath just for that split second. As the brilliant scientist Sir Isaac Newton famously told us, what goes up must eventually come down. So, after that brief moment of weightlessness, everyone begins their descent back towards the Earth's surface. What a sight that would be! Then comes the landing. Thud! All at once, every single one of those 8 billion people lands back on the ground. That's an immense amount of force, a huge burst of kinetic energy being transferred to the Earth's crust in one very, very short period. Think about when you jump up and then land. You feel a little jolt through your body, right? Now, try to imagine that jolt multiplied by 8 billion. It certainly seems like it would create a pretty significant impact, a massive collective stomp felt far and wide. You might expect the ground to tremble quite noticeably from all that sudden downward pressure. What would the people involved actually feel? Well, if everyone was spread out across the globe, most people wouldn't feel anything other than their own landing. However, if we stick to our idea of everyone gathered in one spot, the ground directly beneath them would definitely take a pounding. It would be like dropping an object that weighs as much as a few million blue whales all at once. The ground has some elasticity, meaning it can absorb some shock, but it also pushes back. The immediate area of the jump would experience the most direct and noticeable effect from this tremendous force. And what about the sound? Can you imagine the sound generated by 8 billion people shouting "Wee!" as they jump, or just the collective whoosh of air as they all leap upwards? This would be followed by the enormous synchronized thud of all those feet hitting the ground. It wouldn't be like the low rumble of a typical earthquake. Instead, it would probably be more like a giant, incredibly quick stomp. The sound wave from this massive landing would travel through the ground as seismic waves and also through the air as sound waves, creating a unique acoustic signature for this unprecedented event. So, Here's the big question. Would the Earth actually move from its orbit around the Sun? Could we humans, just by jumping, cause a global catastrophe or shift our planet's path? Well, scientists have crunched the numbers on this very fascinating question, and the answer, perhaps surprisingly, is not really, not in any significant way. You see, our planet Earth is incredibly, unbelievably massive. It has a mass of about 5.972 sextillion kilograms. That's a 5 followed by 24 zeros. It's a truly colossal number, far, far greater than the combined mass of every human on Earth. Let's put that into perspective. The total mass of all 8 billion humans is estimated to be around 400 billion kilograms. Now, 400 billion kilograms sounds like an enormous amount, and it is. If you tried to weigh it on a giant bathroom scale, the numbers would be astronomical. However, when you compare the total mass of humanity to the colossal mass of the Earth, it's like comparing a single tiny ant to a gigantic elephant. Or even more accurately, it's like comparing a microscopic speck of dust to a massive bowling ball. So, even if all of us pushed off the Earth at the same instant, our collective push is just too minuscule to make the Earth noticeably budge in its orbit. Okay, so we're not going to send the Earth careening off into space. That's a relief. But what about causing an earthquake? When everyone lands back on the ground, especially if they were all concentrated in one area, that's a lot of energy hitting the Earth's surface nearly simultaneously. This sudden impact would indeed generate seismic waves, which are the vibrations that cause earthquakes. These waves would ripple outwards from the landing site, much like the ripples when you drop a pebble into a calm pond. So theoretically, yes, there would be a very small, measurable tremor created by our global jump. Scientists have calculated that the energy released by this mass landing would be surprisingly small on a planetary scale. When we all jump, the Earth would recoil an infinitesimally small amount in the opposite direction. Think Newton's third law of motion. Then, when we land, it would move back. But this movement would be less than the width of a single atom. You absolutely wouldn't feel it. The earthquake generated by the landing, if everyone was in one spot, might register as a magnitude 2 or perhaps 3 on the Richter scale. If people were spread out normally, it would be much, much less. Just a lot of tiny, disconnected local rumbles. Think of it this way for a simple comparison. Imagine a tiny mosquito landing very gently on the back of a huge whale swimming in the ocean. Does the whale suddenly change its course or even notice the mosquito? Not at all. The mosquito is just too small and its landing too gentle compared to the immense size and momentum of the whale. We humans, in this jumping scenario, are like those mosquitoes, and our planet Earth is the gigantic whale. Or consider standing on the deck of an enormous aircraft carrier, one of those colossal ships. If you jump up and down, does the whole ship bob noticeably in the water? Nope, the ship is simply too massive. What if we really did manage to gather all 8 billion people into one relatively small area, say the size of a large city like Houston or Tokyo? The ground in that specific location would certainly feel the impact much more intensely. It might cause some localized shaking right under everyone's feet, perhaps even crack some sidewalks or roads in the immediate vicinity of the grand landing. However, this effect wouldn't propagate very far across the globe as a major, devastating earthquake. Our Earth is incredibly resilient and very effective at absorbing these kinds of relatively small shocks. It deals with much, much bigger natural events all the time. So, while it turns out we can't physically move the Earth or cause a global disaster by all jumping at once, this fun thought experiment does highlight something else that's quite profound. It makes us realize just how many of us there are on this planet. And when people act together, even in a hypothetical and slightly silly scenario like a synchronized global jump, it makes us think about our collective presence and potential. We might not be able to physically nudge the planet with a leap, but together, humans certainly have a huge impact on Earth in many other significant ways. Here's a final fascinating thought to ponder. The instantaneous energy from everyone jumping at once is quite a lot, but it's very dispersed if we're spread out or still relatively small compared to Earth's dynamics, even if concentrated. However, if we could somehow harness and focus all the creative and intellectual energy of those 8 billion people, Not just from a physical jump, but from our daily thoughts, actions, and collaborations. Imagine the incredible things we could achieve. We might not move the Earth in its orbit, but together we can definitely move mountains when it comes to solving global challenges or creating a better future. That collective human power is truly awesome.